In this video, we're going to start to think about solving problems. How do you solve a problem? How do you solve a problem in general chemistry? What are the steps that we can use to really start to think about that? And then we'll go through several examples. So in this case, we want to think about what do we even do? Oftentimes what we see is students read a question, they panic, and then they just get kind of stuck. So we're going to outline a couple of steps. So what are some best practices? So one, you can think about one. What do you know? These are the things found in the problem. And so these are often values. You might have to look at a table to get some, but this is where they start. Two, what do you want to know? So if you're given something, what do you want to do with that? So then number three, this is, do you need other information? This would be things like an equation or a constant or something similar, something that would be provided for you, not necessarily something that you would have to just come up with. And so the fourth step would be solve the values. AKA use the calculator. So what we're looking for here is this question of what do we do? So what do you know? What do you want to know? Then in step three, you would basically use the information you have along with any equations and constants to number four, solve the values. It's always worth looking at your answer and asking, does this make sense? If you're asking how fast something is going, and it went from relatively fast to not very fast, you might want to reevaluate, make sure you didn't enter it in your calculator incorrectly, make sure you use your unit conversions correctly. Use all of your tools to see if you're on the right track. So let's think a little bit more practically. So unit conversions, or we can also call this dimensional analysis. Basically, we have a measured value and we want it in a different unit. We saw this previously in things like temperature. In the United States, temperature is measured in Fahrenheit. If we want to think about it in Celsius, we're going to need to convert that using the equation. So a unit conversion uses standard values or conversion factors. These would be provided for you. You can find them within your homework system. You could find them on the internet if you are not using a homework system. So these are going to allow us to have a given unit, in this case highlighted in red, and we're going to use an equation that has both the red and a blue. So oftentimes what we would see is that given unit equals desired unit. And then we can convert that into a dimensional analysis fraction. So some examples of that might be that there are 12 inches in 1 foot. And so, or the pounds to grams. A couple of notes about conversion factors. They have an infinite number of significant figures. What that means is we can't use them to determine any values. So in this case, if what we have is a question about my nephew is 41.1 inches tall. How many centimeters tall is he? So 41.1 inches. And the conversion factor is in 1 inch, it is 2.54 centimeters. So in this case, we have 1 inch, 2.54 centimeters. So if we know that the conversion factor is 1 inch times 1 inch equals 2.54 centimeters, when we plug this into our calculator, what we would get out is 104.394 centimeters. Now, our value only has 3 significant figures, which means that the final answer is 104 centimeters. And so when we think about this, there are so many unique unit conversions. Sometimes you'll need more than one. For instance, if it was a value of inches over something else, such as meters per second or miles per hour, we can use multiple different ones. So let's look at a few additional examples. So I recently purchased a wooden dresser that weighs 108.1 pounds. What is the mass of the dresser in kilograms? Now you'll note that for these examples, the unit conversion is provided next to the question. You would often find that in a table or somewhere else in other instances. So we're going to take our weight, which is the thing that we know, and we want to convert that into kilograms. So we're going to say 108.1 pounds. We want to convert that into pounds or into kilograms. So we have a conversion that takes 1 pound into grams. So 1.0 pound is 453.6 grams. Now, this asks for that in kilograms, and so we need to remember our Greek prefixes, where 1 kilogram is equal to 1,000 grams. And so in this case, when you plug this into your calculator, you should see 49.03416 kilograms. So in this case, the number of significant figures in our starting value is 4. Remember, your conversion factors don't matter. So 49.03 kilograms would be your final answer. So that just required one conversion factor and one Greek prefix. So let's look at another example. Nolan Ryan's fastest pitch was recorded as 100.9 miles per hour. How fast is this in meters per second? So we're going to write this out as 100.9 miles per hour. Now we need to convert these independently. So you could choose to use the 109 miles first or the hours. So I'm going to choose to use the time first. So in 1 hour, there are 60 minutes. In 1 minute, there are 60 seconds. So when we look at this, you'll notice that I'm writing out all the units over and over again. This allows us to determine and make sure that the right units are canceling out. So from here, the hours have canceled, the minutes have canceled. So our value, if we plug this into our calculator, is in miles per second. But it was asked for meters per second. So we know that 1 mile is 1.6093 kilometers. And we know that in 1 kilometer, there's 1,000 meters. So in this case, when we plug this into our calculator, we get 45.11 meters per second. So we want to look at that type of information. So I do want to take a brief second to think about how we might enter this into our calculator. So because there's a lot of different values, so in the calculator, you could set this up a couple of different ways. You could put open parentheses 100.9 multiplied by 1, multiplied by 1, multiplied by 1.6093, multiplied by 1,000, close parentheses, and then you could divide that by 1 times 60 times 60 times 1 times 1. Or you could set these up as two different calculations. There's a lot of different ways you can set this up. Parentheses will be your friend. And so you can set this up by reading all the way across the top. You could alternatively do each unique conversion by itself. So these are a couple of different ways that you can use your calculator. So let's look at some other, perhaps more complex examples. So overall, in these videos, in the upcoming videos, and throughout this type of course, in these courses, we're not going to do a lot of meters per second to miles per hour or miles per hour to meters per second. We're really going to use this in terms of how do we convert or use these numbers. So in this example, we want to calculate the volume of displacement for a 5.72 liter engine block in cubic inches. So in this case, we need to remember a couple of things. That 1 milliliter is equal to 1 cubic centimeter. And we know that 1 centimeter is equal to 2, hold on. We're going to put that in a different way. That 1 inch is equal to 2.54 centimeters. So now we're going to work to convert the 5.72 liters all the way into cubic inches. So we know that in 1 liter, there is 1,000 milliliters. And we know that in 1 milliliter, there's 1 cubic centimeter. Now, we also know that 1 centimeter is equal to 2.54. That's backwards. Let's fix that. We know that 2.54 centimeters is equal to 1 inch. Now, this is asked for in inches cubed, so we need to cube our conversion. What you instinctively want to do is just add the superscript 3 and call it a day. But the reality is that this is cubed and this is cubed. So in this case, we need to have 2.54 cubed as part of our answer. So we would get 349.056 inches cubed when we plug this into our calculator. And with our significant figures, we get 349 inches cubed. So in this type of a calculation, it's important to note that we have to cube the values. So 1 inch cubed equals 1 inch equals 2.54 centimeter. So 1 inch cubed equals 16.4 cubic centimeters. So we can think about how these differ across the board. So let's look at maybe a slightly different example that will be similar to things that we see this semester. So the recipe for honey soy chicken that I like to make calls for 63.9 grams of honey. How many tablespoons of honey does the recipe call for if the density of honey is 1.42 grams per mil and 1 tablespoon equals 14.78 milliliters? So this is going to combine density and unit conversions. So we're going to start with our 63.9 grams. And I'm going to convert that into milliliters first, because we know that 1 tablespoon equals 14.78 milliliters. We need to be able to figure that out. So in this case, we're going to use the density of 1.42 grams in 1 mil. And then we know that for every 14.78 milliliters, it's 1 tablespoon. And so this gives us 3.04 tablespoons. So one thing when we think about this dimensional analysis or the unit conversion is that we want to make sure we're tracking our units. You should always write them out. That way you can see that things like grams cancel and milliliters cancel, so your answer is in tablespoons at the end.